Hi everyone, we're going to be talking about units of measurement today. So usually what we talk about in science are called metric units, and those are all multiples of 10. It's very easy to convert between each unit because it's simply changing from one multiple of 10 to another. So for example, to go from 10 to 100, you would just multiply by 10. Or to go from 100 to 1,000, you would multiply by 10. So the metric unit is simply based on this multiples of 10 system, and it makes it easy to convert between units. However, the science industry decided to come up with a revised version of the metric system known as the International System of Units. So for the most part, it's the same. You have here you have a different type of quantity and your different SI, which are your international units, and your metric units. Now, for length, you have meter, and for metric, you have meter. So those are exactly the same. Mass is a little bit different. You have something called a kilogram, and a kilogram is simply 1,000 grams. And that happens to be the unit for our metric system. So just so you remember, 1 kilogram is equal to 1,000 grams. In temperature, we usually hear of something called degrees Celsius. However, in the SI units, we call something called Kelvin. So this is a little new. And finally, we have differences in time. Or very little difference in time because we both use seconds. So there's no remembering to time or length, whereas mass and temperature are a little different. There's another one that I want you to know. It is known as the volume unit that you use. And your volumetric unit, so this will be volume. Your volumetric unit for your SI system are called cubic meters, also shown as m to the third, and your metric unit is going to be the liter. So that's also one that you should know as well. A big thing to note are your similarities as well as your differences. So you should know your SI units versus your metric units. So if you're looking at length, you have the meter is your main unit. That can be broken up again into smaller and smaller lengths or even bigger ones. And to do that, we have to use something called a prefix, because you don't want to say 0.0000001 meters all the time. You want to have a different unit that can make your life easier. So we use this table of prefixes to help us show if something's getting bigger or if something's getting smaller. So you have kilo, if you remember that. So remember 1 kilogram is equal to 1,000 grams. And the reason I know that is because the meaning of kilo is it's 1,000 times larger than the unit it precedes. So the preceding unit is gram, therefore kilo means times 1,000. If you want to go smaller, you would use the ones down here. And so if you had something like centi, if you had a centimeter, and you had one of those, that means you have something that is 100 times smaller than that of a meter. So that would be 0.01 meters. So you see how you can get either bigger or smaller based on the prefix that you want to use. You do need to know these. You have to know each prefix, the symbol, as well as the factor that it changes. This middle portion is up to you. It will help you understand the factor column. However, you will not be directly asked to write down the meaning on a quiz. So here's a few more examples. The prefix milli, and I just found this from the table on the last slide, means 1/1000, also known as 1,000th. See that TH? So a millimeter means that, here's your milli, so times 1/1000 of 1 meter, which means it equals to 0.001 meters. So go ahead and take a second and take 1 times 1 divided by 1,000 and see if you get this answer. For a bigger distance, we tried to use one of those bigger prefixes from the last slide. So again, here's kilo, which means 1,000. So if you have 1 kilometer or kilometer, kilo means times 1,000. Meter is your base unit. So that means that you would have 1,000 meters. Volume is another thing that we're going to be dealing with in the lab. The SI unit is the cubic meter. However, we usually use something called the liter. Usually that's what your soda comes in, is a 2 liter. And we'll probably also be using a liter. I don't think there's anything in our lab that reads things in cubic meter, so we will have to understand liters instead. And we usually use a graduated cylinder to read the volume of any sample. If you need to go smaller or larger, you also use those prefixes that we have been talking about so far. So milli, once again, means 1/1000. So if you have a milliliter, that means that you have 1/1000 times 1 liter, also known as 0.001. So that's very, very small. So a milliliter is like a drop here, where a liter is more like a what you get your soda in. Here are some more examples of how you can use prefixes with our volume units. It's completely up to you, but you'll see how each one of these prefixes can be applied in our relationship here. This table we don't need to worry about just yet. However, if you do want to see about how much something is, 1 liter is about as big as a quart of milk. 1 milliliter is about 20 drops of water, and so forth. Mass is going to be measuring how much of an object there is. Now, mass, I just want to make sure this is understood. Mass is not weight. Write that down. Mass is not weight. The reason for that is weight tells you how much gravity is pulling on you. Mass tells you how much is in an object. So for example, if you were to go to the moon, your weight would change because there would be no gravity pulling on you, but your mass would not change unless you lost part of your body going up to the moon. The reason for that is it's testing out how much stuff is in that object. Usually, whenever we use SI units, we're going to use a kilogram. And remember, kilo equals times 1,000. But we often, in the chemistry lab, will use grams because they're a lot smaller. Here's some more relationships on the metric unit for mass and some examples. Since we don't often use micrograms or milligrams, it kind of helps you understand how much each one is. This is probably the most relatable. A dollar bill is about 1 gram, so you can see how that's really, really small, whereas a kilogram is about a textbook. Now let's talk about temperature. So temperature, we usually think of it in Fahrenheit. So this orange line right here is showing you that our body temperature is like 98.6. Sorry, that should say 98.6. Sorry about that. However, in Celsius, it is a lot different, right? So in Celsius, you have it at 37 degrees. So we're going to learn how to convert between first Celsius and Kelvin, and then in class, we're going to try a few Fahrenheit problems. So temperature is a measure of how hot or cold something is, and the direction in which heat is transferred, it depends on which one is warmer. So when two objects at different temperatures are in contact, the heat is going to move from the object that is warmer to the object that is colder. So if you were to think of it during the winter, you would want to go towards somebody that has a warmer temperature so that you can steal it away since you're colder. So all that extra heat moves to you. So another way of thinking about it is here's block A that's warm and block A that's cold. Once they come in contact with one another, the warm air from A is going to go towards block B. And it's going to continue to go towards block B until the two blocks have the same temperature. So when you look at a thermometer, it can read a couple different things. Usually we see ours as Fahrenheit. Like I said, we'll talk about that one in class. But in science, we use Celsius, usually with the metric system. And the Kelvin is your SI unit. So the Celsius system has water freezing at 0 degrees Celsius and boiling at 100. Now, the Kelvin scale is an absolute scale. So that means an absolute scale means at 0 Kelvin, nothing moves. And when I say nothing, I mean no atoms are able to move. So that's why they like to use Kelvin as the SI system. You can actually look at the atomic level. So the freezing point of water is 273.15 Kelvin, and the boiling point is 373.5. To learn how to convert between those two, we have this great example here. So the 0 point of the Kelvin scale, like I already said, is absolute 0. And we can determine what our Celsius measurement would be by using this equation right here. So for example, if I told you that you had something that was 85 Kelvin, and I asked what it was in degrees Celsius, I would use this equation here at the bottom. So I would subtract 273, and that gives you your answer of negative 188 degrees Celsius. However, if I give you, say, a degree Celsius, you would use the top equation. If I asked, say, for example, I told you that your body temperature was 37 degrees Celsius, and I asked what it was in Kelvin, you would take the degrees Celsius value that I gave you, add 273, and get your answer of 310 Kelvin. Both of these are the same representation of your body heat, but because of the different scales, you see different numbers. So here's another example. It's all drawn out for you. It's asking you what your temperature is for your human body, but we already actually know this. So let's take a look at how they approached it. So again, you know that you are in degrees Celsius and you want to get to degrees Kelvin. So you would use your Kelvin equation, plug in your number of 37, and get your answer of 310 Kelvin. As always, at the end, there are some great examples of different definitions and things of that nature already included in the PowerPoints online. See you next time.